Objective: to establish a relation between voids and the formula of a compound. You may recall that tetrahedral and octahedral voids are formed when the constituent particles of solids are arranged in cubic or hexagonal close packing. In a close packing, the number of octahedral voids formed are the same as the number of constituent particles or spheres present, while the number of tetrahedral voids is double the number of constituent particles or spheres. Usually, in a closed packing, as anions are larger in size, they form the basic crystal lattice, while cations, being smaller in size, occupy the voids. A smaller cation occupies the tetrahedral void, while a larger cation occupies the octahedral void. For example, in the sodium chloride lattice, sodium ions, 102 picometers in size, occupy the octahedral voids, and in the zinc sulfide lattice, zinc ions, with a size of 74 picometers, occupy the tetrahedral voids. The fraction of octahedral or tetrahedral voids occupied by constituent particles in each lattice depends on the chemical formula of the compound. Let us understand the concept by writing the formula of a compound. Let's take the example of corundum. The oxide ions in corundum form a hexagonal close-packing lattice, and the aluminium ions occupy 2/3 of the octahedral voids. The number of octahedral sites in a hexagonal close packing is the same as the number of constituent particles. For instance, if n oxide ions form the crystalline lattice, the number of available octahedral sites is also n. So the number of aluminium ions occupying the octahedral voids is equal to 2/3 of n octahedral sites. This implies that the ratio of aluminium ions to the oxide ions in the lattice is 2/3:1. Thus the whole number ratio of aluminium ions to oxide ions is 2:3. Therefore, the formula of corundum is Al2O3. Let us consider another example and write the formula of the compound. Consider a crystalline solid whose anions B are arranged in a cubic close packing and cations A occupy 50% of the tetrahedral voids and 50% of the octahedral voids. In the arrangement, the anions B are arranged in cubic close packing. So if the number of anions B is n, then the number of available tetrahedral voids is equal to 2n, and the number of available octahedral voids is n. Cations A occupy 50% of the octahedral voids. That is, cations A are present in n/2 octahedral voids. Also, cations A occupy 50% of the tetrahedral voids, that is, cations A are present in 2n/2 tetrahedral voids. The ratio of cations to anions A is to B, thus becomes 3n/2 is to n. The simple whole number ratio of A is to B is 3 is to 2. Thus the formula becomes A3B2. Hence we can say that there is a relationship between the fraction of voids occupied by the constituent particles and the chemical formula of the compound. Let's summarize. If the number of close-packed spheres in a crystal lattice is n, then the number of octahedral voids and tetrahedral voids generated would be n and 2n respectively.